this is our AP Chemistry Chapter 3 lesson video, Part 5. It is the last part. This is going to be kind of a long one though, because we got a lot to pack in section 3.7 because it includes limiting reagent and percent yield. However, the good news is we already learned this in honors chemistry, so of course this should just be a review. So let's just go ahead and dive in. So the reactant that is completely consumed in a reaction is called the limiting reactant or the limiting reagent. The other reactants are called the excess reactants or reagents. The amount of product is always based on the limiting reagent, not the excess. So let's go ahead and jump in because this should all be reviewed. So it says how many moles of NH3, so that's what I'm looking for, can be formed from 3 moles of nitrogen and 6 moles of hydrogen. Okay, so if you remember, for this type of problem, we do 2 stoichiometry problems. We go from nitrogen to figure out how much ammonia we can produce, and then we go from hydrogen to figure out how much ammonia we can produce. And then the actual amount we'll produce is the lower of the 2. Okay, so I'm just going to start with my 3 moles of nitrogen. So remember, our first step in a stoichiometry problem is normally convert to moles. But if you look, they already gave me moles, so I can skip that step and go straight to mole ratio. So I can see that 1 mole of nitrogen makes 2 moles of ammonia. So I put my 1 mole of nitrogen on bottom, my 2 moles of ammonia on top. Now normally step 3 is to convert to the unit asked for, but I have moles and it asked me for moles, so I don't even have to do that step. So in other words, if I use up all the nitrogen, I will make 6 moles of ammonia. However, we don't know if that's our answer yet because we have to check our hydrogen first. Alright, so I know how much ammonia I could get if I use up my N2. Now let's check our H2. So I'm going to start with 6 moles of hydrogen. Remember, step 1 is normally convert to moles, but we can skip that and go straight to mole ratio. So 3 moles of hydrogen makes 2 moles of ammonia. So I do my 3 moles hydrogen on bottom, my 2 moles ammonia on top. Normally step 3, of course, is convert to unit asked for, but it asked me for moles. So I just multiply and divide, and for this one I ended up getting 4 moles of NH3. So once you know your 2 possibilities for how much product you'll produce, you pick the lower of the 2. Because what that means is once we make 4 moles of NH3, I'm going to run out of hydrogen. It's my limiting. And so we'll never get a chance to get to the 6 moles. This is just saying if I use all my nitrogen, I can make 6 moles. But clearly I don't have enough hydrogen to get that far. So if it had asked me, which it didn't, what my limiting reagent is, you find your lower amount and it's what you start with. Okay, so hydrogen would be the limiting and my excess reagent in this case would be my nitrogen. Okay, so if it ever asks you to identify, that's how you identify. Okay, NH3 is not even a reactant. So remember, when I told you it's called limiting reagent, I said it's also called limiting reactant. So it has to be reactants that you're picking from. Alright, so remember, don't forget to be trying some of these on your own. So it says a mixture of 1.5 moles of aluminum, so we have 1.5 moles of aluminum, and 3 moles of chlorine is allowed to react. Which is the limiting reagent? Okay, well in this case it didn't tell me what I'm going to, but notice I only have 1 product. Or the other thing I notice is I'm only on part A. So most likely part B is going to ask me how much product I produce. So let's go ahead and see what part B says. So it says how many moles of AlCl3 are produced. So now I know I need to go to moles of AlCl3. Okay, so really it just took me needing to click to see what part B is. So that means I'm going to go from here to here, get an answer, go from here to here and get an answer, and then of course pick the lowest of the 2 to figure out how much product I produce. But once I know how much product I can produce, I can figure out which one's limiting and excess. So I start with my 1.5 moles of aluminum. Remember, first step I can skip, so I go directly to mole ratio. 2 moles of aluminum makes 2 moles of aluminum chloride. Alright, third step is usually convert to unit asked for, but I only needed moles. So I get 1.5 moles of aluminum chloride. So again, we don't know if that's our answer. We don't know if this one's limiting or excess yet because we have to check our other one. So we have 3 moles of chlorine So remember, I can skip step 1 of converting to moles and go directly to mole ratio. 3 moles of chlorine makes 2 moles of aluminum chloride. So once I multiply and divide, I end up getting 2 moles of aluminum chloride. So in reality, for part B, I know it's not part B, but we can go ahead and answer. We know we can make 1.5 moles of aluminum chloride. So that's going to be my answer to part B in just a second. But now that I know the amounts I can have, I know which one's my limiting reagent. The one that makes the lower amount, which in this case is aluminum. It didn't ask me for excess reagent, but I always just like to say both of them. So that means my chlorine is my excess reagent. Okay, so that's all you have to do to figure out limiting. Like I said, on the next slide, I'm going to erase, but I'll leave this part right here so that you can see it for part B. So notice part B says how many moles of aluminum chloride are formed. So I end up with that 1.5 moles of aluminum chloride that I just got right here. Okay, so now let's look at the third part. So the third part is something that we didn't actually do in honors. Like we would identify limiting and excess, we'd figure out how much product we could produce, but we never talked about how much excess remains at the end. Okay, so it says how many moles of the excess reactant remain at the end of the reaction. Okay, well I know that, let's see, what did I decide to start with here? Oh, I decided to start with my product and figure out how much chlorine I would actually need to make that amount of product, because we know this is the amount we're actually going to produce. You can go about this many different ways, but let me specify we're going to have to use this reaction, so I just wanted to go ahead and point out is 3 moles of chlorine makes 2 moles of aluminum chloride. So what we're going to do is go from how much aluminum chloride we know we're going to make to how much Cl that would take, and then I can subtract that from how much Cl I started with. Okay, so let's click back here. So I'm going to start with the fact that I know I made 1.5 moles of aluminum chloride. So remember, we don't need the step 1. I can go directly to my mole ratio, which we said 2 moles of aluminum chloride requires 3 moles of chlorine. So once I multiply and divide, I get 2.25 moles of chlorine. So this is how much was actually used. If you notice, I'll click back, we started with 3 moles though. We only used 2.25. So then I can just subtract. So 3 moles of chlorine was how much I started with. We used 2.25 moles of chlorine. And so of course, once I subtract, I get 0.75 moles of chlorine that were unused. Okay, so this is like what's left over. All right, and again, you don't have to start with the product on this. You could have started with how much aluminum you used, because that's the substance that's actually going to run out. There's many different ways that you can solve most math problems. Okay, so like on this one, like I said, I just chose to start with how much product I knew I would produce. All right, so remember, don't forget to be trying some of these on your own. It doesn't help if I know how to do them. It helps if you know how to do them. So it says, suppose a fuel cell is set up with 150 grams of hydrogen gas. So we have 150 grams of hydrogen and 1,500 grams of oxygen. How many grams of water can be formed? Okay, so again, I'm just going from here to here to get an answer, from here to here to get an answer, and then I'll pick the lowest of the two. Okay, so I'm going to start with my 150 grams of hydrogen. Now, because we've already done basic stoichiometry in the previous video, I'm going to do these steps pretty quickly. Okay, so I'm going to change from grams to moles. So 2 grams, which is my molar mass of H2, is 1 mole of hydrogen. Next is mole ratio. 2 moles of hydrogen makes 2 moles of water. All right, last step is convert to unit. It asks me for grams of water. So the molar mass of water is 18 grams in 1 mole. And see, y'all, you've got to get where you can do these stoichiometry problems pretty quickly. Okay, again, the test is timed. You don't want to spend forever trying to figure out these answers. All right, so if I use up all my hydrogen, I can make 1,350 grams of water. All right, next I got to start with my oxygen. So here we have 1,500 grams of oxygen. So step 1 is convert to moles. So my molar mass of oxygen is 32 grams, is 1 mole. Next is mole ratio. I can see 1 mole of hydrogen makes 2 moles of water. Sorry, 1 mole of oxygen makes 2 moles of water. And last step is to convert to unit asked for. So I'm looking for grams of water. So I can see that 1 mole of H2O is 18 grams of H2O. So once I multiply and divide, I get 1,687.5 grams of H2O. So in reality, how much water will I actually produce? It'll be the 1,350 grams of water. Now, of course, if you're doing significant figures, this would round to 1,400. Just throwing that out there for significant figures purposes. All right, so let's move on and just remember, make sure you're trying these on your own. So it doesn't matter if it's moles, grams, atoms, molecules, liters, they all work the same. Okay, so I can already see this one has a part A. So it's asking me about limiting a reagent. So let's go ahead and see what we're going to. So notice it says how many grams of silver will form. It also asks me how many grams of zinc nitrate will form. So I can actually go to either of them, but I'll start by going to silver. But pretend like we didn't see what the limiting was. All right, so it says a strip of zinc metal with a mass of 2 grams is placed in an aqueous solution containing 2.5 grams of silver nitrate, causing the following reaction to occur. Which reactant is limiting? Well, since it's asking me about silver anyway, I'm just going to go to silver. So I'll go from here to here, here to here, and then of course pick the lowest. So I start with my 2 grams of zinc. First step is convert to moles. So molar mass of zinc is about 65 grams, and that equals 1 mole. Next is, of course, mole ratio. So I can see 1 mole of zinc makes 2 moles of silver. All right, last step is it does ask me how many grams of silver. Okay, so I am trying to get to grams. So I can say, okay, well, 1 mole of silver is 108 grams. So once I do that, I can see if I use up all my zinc, I will make 6.65 grams of silver. But again, I don't know if that makes zinc the limiting or not until I try the other one. Okay, so now I'm going to start with my 2.5 grams of silver nitrate. So of course, first step is change to moles using molar mass. So the molar mass of silver nitrate is about 170 grams, and that's in 1 mole. Second step, of course, is mole ratio. So I can see 2 moles of silver nitrate makes 2 moles of silver. All right, last step is, of course, to get to grams of silver. So I can use the same step. 1 mole of silver is 108 grams of silver. So once I multiply and divide for this one, I got 1.59 grams of silver. So for part B, I can go ahead and see this is my answer for part B, 1.59 grams of silver. But part A asked me which one's limiting. So I know that my limiting reagent is AgNO3 because that's the reactant that made the lowest amount. And again, it didn't ask me for my excess, but I can see my excess reagent is zinc. Okay, and so you can use this answer for part B, just letting you know. All right, so let's move on. So part B, of course, said how much silver would form, so we got 1.59 grams. Well, then it says how much zinc nitrate will form. Well, we've already determined that our limiting reagent is the silver nitrate. So that means I need to start with the silver nitrate to determine how much of my other product I'll have. So if you remember, we started with 2.5 grams of our silver nitrate. That's what it told me in this problem. Right here, 2.5 grams of silver nitrate. Another thing we need to keep in mind is 2 moles of silver nitrate makes 1 mole of zinc nitrate. Okay, because we're going to need that mole ratio. All right, so first step, of course, is to convert to moles. And so my molar mass of silver nitrate is about 170 grams. and that equals 1 mole. So then next is my mole ratio. So we said that 2 moles of silver nitrate is 1 mole of zinc nitrate. That we pulled from the previous reaction on the other slide. All right, and then last step, it does say how many grams of zinc nitrate, so I need to use molar mass of zinc nitrate. So when I add it up, I get about 189 grams. So 1 mole of zinc nitrate is 189 grams of zinc nitrate. So then I'm just ready to multiply and divide. So I get about 1.39 grams of zinc nitrate. So don't let it throw you off if it's a multi-step problem and it asks you to go to one product but then asks you to go to another product. Either product you go to, you have to start with the limiting reagent every time. So then, this is the new one we just did a few minutes ago. It says how many grams of the excess reagent will be left. Well, I can start with many things. I could start with my grams of silver nitrate and go to my zinc. I could start with 1.59 grams of silver and go to my zinc, or I could start with 1.39 zinc nitrate and go to my zinc. I could do any of those. So let's see which one I picked. I picked to start with my limiting, I picked to start with how much silver I would produce. Okay, so I started with 1.59 grams of silver, change that to moles. So of course 108 grams of silver is 1 mole. All right, now I'm going between silver and zinc. So if you look back at our reaction, we can see that 2 moles of silver requires 1 mole of zinc. Okay, so 2 moles of silver requires 1 mole of zinc. Oh, we got to get to grams because we're trying to figure out how many grams we have left over. So my molar mass of zinc is 65 grams. So 1 mole zinc, 65 grams zinc. So once I multiply and divide, I get 0.48 grams zinc. Now this is not how much I have left. This is how much was used to create the silver. Okay, so we use this much. So if I go back to my question, I can see we started with 2 grams of zinc. So now that I know how much I used, I can just say, okay, well 2 grams of zinc minus 0.48 grams of zinc gives me 1.52 grams of zinc. And so that is what's left over. Okay, so the important thing is when you're calculating excess, don't just figure out how much excess you use. You then need to subtract that from your starting amount. Alright, so hopefully you've been getting these right. Really the only kind of tricky one would be calculating that excess reagent, how much is left over. Alright, so percent yield was also something that we did in honors. So percent yield of a reaction relates to the actual yield, which is done in the lab, to the theoretical yield, which is calculated using stoichiometry. So percent yield is actual over theoretical times 100. We did this before. Since the theoretical yield is the maximum amount of product that can be produced under ideal conditions, the actual yield should never be larger than the theoretical yield. So in other words, your percent yield should never exceed 100%. So let's go ahead and jump on in. Boy, I did not leave myself a lot of room for writing up here. Alright, so it says adipic acid, and there's the formula, is used to produce nylon. Adipic acid is made from the following reaction. So here's our reaction. Assume you carry out this reaction starting with 25 grams of cyclohexane. Alright, so we have 25 grams of cyclohexane. Now you may be looking at this reaction thinking, how the heck was I supposed to know that cyclohexane? Well, first of all, they told you this is adipic acid. You know this is oxygen, and you know this is water. Okay, another way you can tell is hex means 6. And when we're talking about, from chapter 1, when we talked about alkanes, hexane would have 6 carbons. So that's another way you could have figured it out. Alright, so it says, assume you're starting with 25 grams of cyclohexane, and that cyclohexane is the limiting reagent, so we don't need to worry about how much oxygen we have. What is the theoretical yield of adipic acid? Alright, so let's see, I think I just went to grams. It didn't technically specify, but there was a part B, and part B says if you obtain 33.5 grams. Okay, so that means we definitely want our answer to be in grams because there was a part B. Alright, so that means I'm going to go from here to here to figure out how many grams of adipic acid I should have created under perfect conditions. And to save from writing this huge formula, you're just going to see me call it acid when I'm writing it. Okay, so we start with our 25 grams of our cyclohexane, C6H12. So first step, of course, is convert to moles using molar mass. So my molar mass, wrong page, my molar mass for C6H12 is about 84 grams. And that equals 1 mole. My next step, of course, is mole ratio. So I can see 2 moles of the cyclohexane makes 2 moles of the acid. So I'll put my 2 moles of C6H12. That makes 2 moles of my acid. So see, notice I'm just calling it acid to keep from writing that gigantic formula over and over again. All right, so I need to get to grams. So I know 1 mole of my acid just equals the molar mass. So when I add up the acid, I get 146 grams. So once I multiply and divide, I get about 43.5 grams of my adipic acid. Just like that. Okay, so since we calculated this using stoichiometry, this is my theoretical yield. This is in theory what we should have made. Okay, I'm going to leave this up because for part B, we're going to need that number. So then part B says, if you obtain 33.5 grams of adipic acid from your reaction, so see, they're saying if this happened in the lab, so that's my actual, what is the percent yield? Well, remember, percent yield is just actual over theoretical times 100. So I just plug in. So we actually made 33.5 grams. We theoretically should have made 43.5 grams. And then times 100 to make it a percentage. Grams cancel. So once I divide and multiply by 100, I should get about 77%. Okay, so we had about a 77% yield. We didn't quite make what we should have. Alright, so maybe make sure you're pausing. So pause the video and try the next one on your own. And this is the last one for chapter 3. Boy, chapter 3 was kind of long. Alright, so we have a part A and part B. So it says if you start with 150 grams of Fe2O3 as the limiting reagent, what is the theoretical yield of Fe? So we're looking for Fe. We don't know what they wanted in yet, but if you look at part B, it tells you the actual yield in grams. That means I want the grams. So I'm just going to go from here to here to get my theoretical yield. So I start with my 150 grams. So 150 grams of Fe2O3. First step is change to moles using molar mass. Molar mass of Fe2O3 is about 160 grams. And that equals 1 mole. Next step, of course, is mole ratio. I can see that 1 mole of my Fe2O3 makes 2 moles of Fe. So I'll put that in next. And then last step, of course, is to get to grams. So I know 1 mole of Fe equals its molar mass of about 56 grams. So once I multiply and divide, I get about 105 grams of Fe. So remember, this right here, we did not do this in the lab, we calculated it, so this is our theoretical. In theory, we should make 105 grams. The thing that happens is in the lab, a lot of times you don't get 100% of what you try, just because of various factors. Okay, so it says if the actual yield in your test was 87.9 grams, so there's my actual, what is the percent yield? Okay, so we know percent yield is actual over theoretical times 100. So my actual is 87.9 grams. My theoretical we calculated was 105 grams times 100. Those grams cancel. And so we get about 83.71. And then our unit for percent yield is percent. Okay, so again, hopefully this is kind of jogging your memory about limiting reagents, excess reagents, and percent yield. Because again, this is all review. If you're struggling with this, you need to go back to my honors chemistry videos for chapter 12 because that's when I covered this the first time.